Section 5.1 is about fundamental identities, and we've had quite a few that we've been accumulating. So let's look. You already have these. We know the reciprocal ones, where cotans equal to 1 over tan or tans equal to 1 over cotan. So these are the reciprocal identities. And then the quotient identities are the tan and the cotan, where you turn them into cosine and sine. Then we have the Pythagorean ones, and those are here. And these are the three that are the Pythagorean. Sine squared plus cosine squared equals 1. Tan squared theta plus 1 equals secant squared theta. And 1 plus cotan squared theta equals cosecant squared theta. Now, those are three that you're usually given in most identity sheets. You can rearrange this one, as I've shown here. If I subtract cosine squared, I get what sine squared is. If I subtract the sine squared, I get what cosine squared is. So you may use these, but they're not usually printed somewhere. They're things that you could come up with on your own. Then there's some negative angle identities right here. And so those would be important as well. And let's see how some of these work. So the negative angle identities, if cosine x equals negative 65, then cosine of negative x equals cosine negative x equals negative 65, because whatever cosine is here, it's also equal to cosine of negative of the angle. So cosine of negative 65, cosine of negative equals cosine of theta. Number 3, if cosine theta equals 3 over 4 and theta is in quadrant 1, find sine theta. So we could do this a couple of ways. You could do it with a triangle, but if you're using identities, you want to look for an identity that relates sine and cosine. So we have sine squared plus cosine squared theta equals 1. So if I write that out, plug in my 3 over 4. Well, you square that, you get 9 over 16. Subtract that, because we want to isolate sine theta. So sine squared theta equals 7 over 16. Take the square root of both sides. Sine theta equals plus or minus the square root of 7 over 16. We can take the square root of that, so we have a 4 there. So sine theta is square root of 7 over 4. Cosecant equals, if cosecant theta is negative 8 over 5, find sine theta. Well, those are reciprocal, so you just flip to get that one. Cosine theta is 1/5 and theta is in quadrant 1. Find the remaining trig functions. So we can start out by finding sine squared theta is equal to 1 minus cosine squared theta. So let's go over here and do a little bit of work for that one. Sine squared theta equals 1 minus 1 over 5 squared. So sine squared theta equals 1 minus 1 over 25. Sine squared theta equals, so this is like 25 over 25. I'm writing all of it out, which equals 24 over 25. Now, the square root of that, sine theta, equals the square root of 24 over 25, which equals the square root of 24 over 5. We do have to simplify the square root of 24. That's equal to the square root of 4 times the square root of 6, which is 2 square roots of 6. So 2 square roots of 6 over 5 would be sine theta. Cosine theta we were given. Then tan theta, you would put this over this, divide. So you would have 2 square roots of 6, whoops, 2 square roots of 6 over 5 times 5 over 1, because when you divide, you flip and multiply. That's gone, so you're left with 2 square roots of 6. Once you have these three, you can just flip and rationalize where you have to. Tan theta is -1/4, and theta is in quadrant 4. So why do they tell us that? Because in quadrant 4, tan is negative, cotan's negative, and the only ones that are positive are cosine and secant. So we can use this, we can use this. Tan is equal to sine over cosine. So -1/4, -1/4 equals sine over cosine. I think we're going to skip down. Let's skip down to here. This is the Pythagorean identity. So we only have the -1/4 squared. So here's our identity. We put this in for tan, and we have 1 over 16 plus 1 equals secant squared. That's 16 over 16. So we end up with 17 over 16 is secant squared. The square root of that is the square root of 17 over 4, because you can take that one. Once you have secant, you can get cosine. So you flip it and you have 4 over the square root of 17. So when you want to get the cosine and you flipped it, you have 17, square root of 17, you have 4 over the square root of 17, and you rationalize that times the square root of 17 over the square root of 17, and you get 4 square roots of 17 over 17. So let's see, we have the first three here. Then you're given the tan, and we figured out what sine and cosine were. Then you flip those and rationalize when you need to. This one, 35, that I have here says secant squared x minus 1 equals. Well, the identity is here that you're given, and you could tell that if you subtract this 1 over here, you get this. So you're left with tan squared x. For 36, what you want to do is try to change everything you can into sines and cosines. Well, secant x is 1 over cosine x. Cosecant x is 1 over sine x. This is a division, so we're going to flip this one and multiply. So now we've got sine x over cosine x, which again simplifies to tan x. And while these won't seem really easy at the beginning, the more you do, the better you'll get at them. Number 44 says write in terms of sine, which means you're only allowed sine x or some form of sine in the final answer. All right, so cotan x is equal to cosine over sine. So this sine's okay. We need to figure out what cosine could be. Well, remember where I said you could write cosine squared x equals 1 minus sine squared x, and then take the square root of both sides. So this is the same as cosine x. So your final answer would be square root of 1 minus sine squared x over sine x. That would be the same as cotan, but in terms of sine. And I think that will get you on the lecture notes. Let's go look at the problem set. All right, number 1, choose the expression that completes the identity. Cosine x over sine x equals cotan x. You want to have your sheet of identities that you've printed available for you as you do your homework. Tan squared x plus 1 equals secant squared x. Number 3, for the expression in column 1, choose the expression from column 2. So it says 1 equals. Well, we know that sine squared x plus cosine squared x equals 1. So it would be this first one A. Negative tan x cosine x equals. So what I did was take tan x and turn it into sine and cosine. So that's negative sine x over cosine x times cosine x. Those go away and you are left with negative sine x or sine negative x. Number 5. 1 minus cosecant squared x equals negative cotan squared x. Go a little further and you get negative cosine squared x over sine squared x. Again, have your sheet of identities. That will help you initially. If sine theta equals 0.853, then sine of negative theta equals the negative of that value. If tan theta equals 2, then cotan theta equals, you flip 2. So instead of 2 over 1, you have 1 over 2. It wants a whole number or a decimal, so change it to 0.5. Number 8. Cosine S is equal to 1/2, and S is in quadrant 1. So we can use triangles to do this as well. So I drew a triangle in quadrant 1, and here is S, the angle. Cosine is adjacent over hypotenuse. So 1 over 2. We had to find the missing side, and we did that. 1 squared plus y squared equals 2 squared. So y squared equals 4 minus 1. Y is the square root of 3. Once you know that, you're asked to find sine, which is opposite over hypotenuse. So square root of 3 over 2. Number 9. Cotan theta is negative 2/5, and theta is in quadrant 4. So if we draw the angle here, always come out from the origin and then go back up to the x-axis. So cotan is adjacent over opposite. So your 2 goes there, negative 5 goes there. You find your r by using the Pythagorean theory, and you get r is the square root of 29. So then sine is negative 5 over square root of 29. We rationalize it, and we get negative 5 square roots of 29 over 29. Number 10, cosecant theta is negative 8 over 3. Find sine. Well, sine is 1 over that, so you just flip, and you have negative 3 over 8. 11, write sine x in terms of cosine x. So we start out with the identity that has both of them. Sine x equals 1 minus cosine squared x. Sine x is plus or minus the square root of that. So we have this last choice. Number 12. You could watch the video if you need to. Write the first trig function in terms of the second trig function. So we're going to put cotan x in terms of cosecant x. So something that has both of them is the identity 1 plus cotan squared x equals cosecant squared x. So we will subtract the 1. So cotan squared x equals cosecant squared x minus 1. Then we'll take the square root of both sides, and we end up with plus or minus the square root of cosecant squared x minus 1. You do the same thing here. It says put everything in terms of sine and cosine, and then simplify so that you don't have any quotients, and your functions are of x only. So cotan x, sine x. Change the cotan x into cosine over sine. Sines cancel out. You're left with just cosine x. Do the same thing with this one. You've got cosine theta, cosecant theta, tan theta. So we leave that one. We change cosecant to 1 over sine. We change tan to sine over cosine. Then we're multiplying across top and bottom. The sines cancel out. The cosines cancel out. We're left with 1. 15. Do the same thing with tan x, cotan x. Now we could know that those are reciprocals, and if you multiply them together, you get 1. But if we change them to sine and cosine, because that's what this says here, you have sine over cosine times cosine over sine, cancel, cancel, and you are left with 1. Number 16, write in terms of sine and cosine. So cosine beta minus secant beta. Secant is 1 over cosine. So now we have to make this be one fraction. So think about it this way. You've got cosine over 1 equals something over cosine. The only thing that would make that would be cosine squared. So we have cosine squared beta minus 1 over cosine. This is equal to negative sine squared. And so we have negative sine times positive sine over cosine beta. That is tan, so we have negative sine beta, tan beta. That one is a little confusing, but hopefully that will help you get the homework questions done.